Hello everyone, welcome to our MPLS and segment routing basic to advanced series. This is our third session in this series, and today we will be talking about some label based forwarding. Basically, how does it work? The session number 2, when I uploaded, there were few queries that I got from you guys, and I will try to address them in this video. And those were related to this label based forwarding. So we will discuss this. Then we will talk about why a label stack is needed on a packet. Why more than one label is needed? That will be our second item on the agenda. And third one is we will talk about some of the special labels and why they are needed. So this lecture is for absolute beginners or who have some 3 to 4 years of experience in this service provider network. For those of you who are experienced, feel free to fast forward this. You may find something which can refresh your knowledge. So with that, let's just get into the session. So the label based forwarding. Here I have a simple topology from PE1, P1, P2, P3 and PE2. Let's say that I configured a loopback address here. And this loopback I give an IP address of 2.2.2.2. First, we will complete the control plane path and then we will see how does the label based forwarding happens in the data plane. And I will also talk about some of my thoughts into this, that when I looked at it initially, I reached out to few of my mentors as well. So let's say in this entire chain of routers, we are running OSPF. So via OSPF, when we enable this OSPF on this loopback, this route will travel in this direction. So basically, all of these devices will have the route for 2.2.2.2/32. Now, because we don't want IP based forwarding, we want label based forwarding, and this is the simplest scenario that is possible. So, what I did by watching, let's say, my previous lecture, I configured LDP. So, LDP is configured on all these nodes. And then, when LDP was enabled, what I told you, LDP assigned the label to all the IGP based destinations. So here my loopback address, I am advertising it in IGP. So that means when PE2, because this route is directly here and LDP is enabled, PE2 will have some label for this, and that label will also travel in this direction. So let's say that label that PE2 advertised, just a hypothetical scenario, is label 20. So PE3 will receive this label 20, and then PE3 had also received this route via OSPF. That means P3 will also allocate a label, a local label on P3 will be allocated for this destination because this route is available via OSPF. Let's say that label is 30. And then remember, the job of LDP is to not only allocate labels but also to distribute them. So that's how LDP When PE2 allocated label 20, LDP did that, and LDP had also distributed that to entire peers which are connected to PE2. In this case, it is PE3 only. Then PE3 allocated a label and distributed it. So the label came to P2. Now P2 also will allocate a label. Let's say that label is 40. LDP allocated the label. LDP has to distribute this label. So LDP will distribute that label. Let's say that's how the label come here on P1. So P1 will also allocate a label. Let's say that's 50, and that 50 will come here, right? So the labels are allocated hop by hop, and they are distributed to their peers. Now, in our last session, I have talked about this, that P2, it's allocating a label 40, but LDP is running both sides. That means LDP will send this label 40 in this direction also. So P3 will receive label 40 via P2 from this direction as well. But now, looking at the topology, you can see that P3 is the router which had sent this route via OSPF to P2. So how can P2 allocate a label and send it to P3? We will see how this is not a problem with LDP. So here we will come back to this problem. Let's hold it for now. But now let's say PE1 initiate a packet. Let's say here I have a loopback 1.1.1.1. I am initiating a ping from 1.1.1 to 2.2.2. Because this is a MPLS based interface, I had enabled MPLS on all these interfaces. That means MPLS based forwarding will work. So what PE1 will do? PE1 will check the routing table first. PE1 will do show IP route 2.2.2.2, and that route it has received via OSPF. Remember our OSPF from P1. So it knows that okay, the packet need to go out on this interface towards P1. That information OSPF had given. Then P1 will look what is the label allocated for this. It will check its label forwarding information base, what label has been assigned by LDP for this path. Which path? The path which is chosen by OSPF. So it will have that IP packet, and then it will put the label 50, because 50 is the label which this guy had given, and OSPF told P1 is your next hop. So the packet will come with label 50. So when label 50 it come here on P1, what P1 will do? It will maintain a table where it has advertised upstream the label 50, what it has received from the downstream the label 40. So it will simply swap that label with 40. The packet come here. So PE3 has sent label 30 for this, for which P2 has allocated 40. That means the top label will be swapped with label 30 and send it in this direction. Here 30 will be replaced with 20 and packet will be sent to P2. Now P2 is the one who had allocated this label 20. There is no label forwarding path there. P2 will also check its routing table then, and then it will see that 2.2.2 is directly connected, so the packet will be forwarded here. So all these nodes in between, they will just check the top label only and perform a swap operation. They will not look at the inner IP packet. That means even if P2, which has allocated label 40 and send that here towards P3, that is not a problem, because here the forwarding is not happening based on IP. The forwarding is happening based on the label address only. And this LSP that has been formed, let's say, in this path, a unidirectional LSP, which have its label already allocated for the prefixes, and those are installed in the forwarding table. So this incoming label, swap it with this outgoing label, no brain. Only at the ingress router, you check what is the route to reach for a particular destination, in this case 2222, and what is the path. So this path is advertised by OSPF. OSPF will tell PE1 that you send this packet towards P1 and use the label which has LDP allocated for this path. So OSPF is directing that to PE1, right? That's how the packet reaches the correct destination. So LDP only allocate label. When it comes to choosing the path, that will be your IGP in this case, and IGP decide where to send, and then LDP, which has already allocated the label, so whatever label is allocated for that path, that label will be used. So issues like this, where the lack of split horizon will not be an issue in LDP, because LDP only give the label. Forwarding decisions always happen based on IGP. So this is how your label based forwarding works at a high level. But did you guys notice one thing here, that all these nodes, they are assigning the labels independently. Of course, there is a protocol which is LDP, which is used, but these labels are different. And normally in our day-to-day life also, when we put a label, we put certain label, and that label is used throughout the picture to identify that particular packet. So this was something I asked my mentors, like why they are using different label. Can't there be a certain mechanism in this LDP itself which allocate the same label on each hop? So that time the answer that I got is that each of these node work independently, and they are running their own instance of LDP, which makes sure that the label is unique on that platform itself, but there is no guarantee that that label will be unique in the entire network. But we will see that how this picture is changing with segment routing. I will revisit this point when we will start our segment routing sessions, and then we will discuss how SR allocate the label, or does this thought which I was asking has any significance in the SR based networks. So with that, let's just move on to our next topic, which is label stacking. So in the last scenario, I have told you there is only one label and that swapping happens. But we can very well have a label stack as well, where on a packet I can have more than one label. Let's say here 50 and here 60. Why in the first place we need two labels? Let's just discuss that. So before I get into the technical aspect of this, I still remember when I was learning about this, I remember a story. So this was back in 2003 when I was in school, and I remember that during the October to November time frame, there used to happen some competitions, and after those, our principal used to distribute some prizes. And that year, our school had also won an inter-school tournament in sports, and he was very happy. So then he said, or he instructed his staff, that whoever was the part of the team, the winning team basically, I want to give them a special prize. So there was some prize like this was ordered, and because this was already ordered, the staff was confused like what special prize means here. But then they saw that some of the prizes which came were a little bigger inside. So they decided that okay, these bigger size trophy, a little bit bigger, we will give to the winning team. But there was a slight difference. So how they will communicate this to the principal, because in the assembly there will not be enough time for this, and there was the size of the table was like small, and they just needed to put all the prices on that table itself. So there were some chances of mistake until and unless somebody is standing near to the principal and tell manually. But that was not the possibility because they were there in the assembly at multiple places. So one of the teacher came up with the idea. What he did is, like our principal, he used to have certain label per class on the prize itself so that he can simply look at it. For example, if 10 is written, that is for class 10th. If ninth is written, that is for class 9th. What they did is, these teachers, they put a second tag near to this with a star on it. This doesn't look like a star, sorry, but there was a star label, a second label they put, and they told the principal that this whatever prize have two labels on it, that means that is for the winning team. So it can be for class 10 with a star tag. So whoever took part from class 10 and was there in the tournament will got this prize. Then if this label is 9 and the person is a part of the winning team, he will get that prize. So the upper label was specifying the class, the lower label was specifying actually the people who won that sports tournament. So two labels solved this. Nobody was standing near to the principal to tell this. They just told one time that, sir, you follow this approach, and the prize distribution was correct. This is what I realized when I first encountered with label stacking. So this top label that can be used for distribution, and the second label can be used for some sort of identification within that group. So if we come at our slide, so the top label, the transport label, which help to get the packet from A to B, the way we had seen in our previous example. And then the bottom label, this one, is actually identifying certain services. What do I mean by that? Let's say I have these two devices. I have VPN 1, VPN 2, and VPN 3. Here also VPN 1, VPN 2, and VPN 3. In between, let's say there are many devices, right? MPLS is enabled. So I will put a bottom label, let's say label 10 for VPN 1, label 20 for VPN 20, and label 30 for VPN 3. And then top label I will use, which will help me to reach from device A to B. Device A to B. Once it reaches at B, B will do a lookup, and if it sees that it is labeled 10, it will forward to VPN 1. So you see the significance of two label, one label, which will help me to get the packet from here to here. Once the packet reaches here, I need to forward that to either VPN 1, 2, or 3. That identification also based on 10, 20, or 30, this guy will do and forward the packet to the correct VPN. And that is why, my friends, we need label stacking in MPLS applications, and there are multiple examples of this. In our upcoming session, I will show you a packet walk also, a packet walk for MPLS VPN. Right? In that, we will use two labels, and I will show you the same analogy how the packets get identified or travel on the wire. So stay tuned for the next session for that. And then there are certain special labels as well, which are used for some special treatment. We will look at in few minutes from now. What are those special labels and why we need them? So with that, let's just look at some of the label operations. So in our previous animation where I was showing you the label path between multiple devices, they all forward the packet based on the top label. Let's say this side 30 and this guy is giving 40. So in the data plane, my label 30 will come here. When this, let's say P1 forward the packet, it will simply swap that 30 with 40. And then it will send that. And here also the same thing will happen. So label 40 will be swapped with 50 and packet will travel in this direction. So this is how the LDP has allocated the label, and in the forwarding we see this. So based on this, what could be the possible operations? One of the operation that you see here is that this top label is getting swapped. That means we have this swap operation. So the first operation is swap. The second operation is somebody has to insert these labels as well, right? This ingress node, when the packet is coming as IP and the path forward is MPLS based path, that means this node has to push the label. And same way towards the egress, the path forward is IP, that means you can't forward label based packet on that path. That means you need to pop the label and send the packet as IP or in its original form. So that way there are these three operations that happen: the swap operation, push operation, and pop. Push at the ingress, swap at the transit, and pop at the egress. This is the highly simplified label operations that you will see in a MPLS based forwarding. Right. Now you may be asking, let's say if we talk about this OSI model, we have our network layer, we have our data link layer. Where exactly the label forwarding comes? Because if it is IP based forwarding, we can say it is layer 3. If it is MAC based forwarding, we can say it is layer 2. But if it is label based forwarding, what exactly it is? That is your layer 2.5 that you can call, because the label stack come in between of your layer 2 and your layer 3 header. So that is where the MPLS label gets fit in between the layer 2 and layer 3. Now, what happens when a packet comes with the unknown label? When a router receives a IP packet, and if that IP route is not there in the routing table, the router just drop the packet. Same way, if a packet comes with a unknown label, or if the label switch router, LSR stands for label switch router, if it does not identify the top label, the action is dropped. This is quite obvious. So why in the first place I am telling you this? Because some of the folks may not know this. If I ask you, why can't there be a fallback? In IP, we have something called as a default route. Let's say, so if a IP based packet is not meeting any specific destination, it will be forwarded on that default path where that default route is pointing. Why can't there be something like that with the MPLS packet? Because in MPLS, the inner payload can be IP, inner payload can be a Ethernet frame, or inner payload can be anything. And the intermediate node, even if they want to help by forwarding it, they cannot, because they may not have the correct path to forward it. All these intermediate nodes, let's say, they are all layer 3, right? So if a layer 2 packet come here with the unknown label, the only option that this node have is to simply drop the packet. It cannot basically forward it. So now let's just talk about some special labels. And first one is implicit null. This is the topology that we have used at the start of this session. And here I have told you that there is a loopback configured, which is 2.2.2.2, right? And then I told you there that PE2 is allocating, let's say, a label 50 and sending it to P3. And P3 will allocate, let's say, some label 40 and send that or distribute that via LDP. But then when the packet comes with label 40, it will be replaced with label 50, and then the packet will come to PE2. Now here, think from a PE2 perspective. PE2 first need to look at this label 50, and then it will see and look up that this label is allocated by itself only, so it will remove that label, and then it will look at this IP, and then it will figure out that this IP belongs to 2.2.2.2. So then the packet will be forwarded here. So first the label based lookup is happening, and then the IP based lookup is happening. Can we avoid it? So if you see from the topology perspective, this 2.2.2.2 is directly connected. This loopback address that I see here is directly connected. That means if I just send some reserved label, let's say label 3, which is a reserved label because it falls under 0 to 15 category, to P3, and that label 3 means that whatever the top label that you see here on a labeled packet, you simply don't put any label on that and just send me the packet which is underneath. That means when the node is signaling a label 3 to its upstream node, they are removing that top label. In this case, there was only one label, so 40 was removed and IP packet is forwarded to PE2. PE2 will only do one lookup now, that is 2.2.2.2, and it will forward the packet. That means we are saving on multiple lookups if we send this label. This label is used for the directly connected destinations only. Let's understand that from a high level. Because 2.2.2 is directly connected, I will say or signal label 3. That label 3 will instruct the upstream node to pop the top label. And this label, because the pop operation is happening here, like taking off the label, so you will not see this label 3 on the wire. So label 3 will not be present in the label stack. It is just a method of signal to the upstream node that you remove the top label, in this case 40. Remove the top label, and this is used for penultimate hop popping. So this is the penultimate hop where you perform the pop operations. But now this scenario, which is used for optimizing the lookup on the egress node. But if you recall our MPLS packet, right, there is this label value that is 20 bit, then there is traffic class bits, then there is bottom of stack, and then there is this TTL. So if there is some sort of traffic class that this label belongs to, the moment you pop the label, this TC class will also go off. That means PE2 will not be aware what traffic class this label belongs to, because the label is already popped by the previous node. So how to address this? One way is that you do to lookup, like the way I was describing in my previous animation that I did just for simplicity. But actually this work like this. But how to handle this traffic class? So one thing is, if you are not using any type of QoS, let's say, then you fall in this category. You can use this label 3 very well and your job is done. But if there is a QoS deployed, and remember, QoS is deployed end to end. Right? So each of the node should honor that QoS SLA. That means we have a problem here. So to address this problem, there was another label which is basically label 0. So instead of signaling 3, it will signal label 0. And in that, there will be this PC class that you will see. So this label is used to carry the traffic class to the end router. So with explicit null, the label will not be popped. It will be again a swap operation, but with this special label. And implicit null is the default behavior, and this one is something that you need to configure. So with that, let's just move on to our last label, which is MPLS OAM. This is nothing but your operation and administration maintenance, right? It is label 1. Whenever this label is there at the top label, each of the node will forward that packet in a special manner. What I mean by special manner? In the hardware, basically the packet forwarding happens based on your ASICs, right? We say that there is an ASIC which just forward the packet. But if there is this special label, that packet will always be punted to the CPU and it will have some special treatment. And normally OAM, without going into much detail, they are used for administration and maintenance. That means for troubleshooting, MPLS ping, MPLS trace. If you need more details on that, feel free to put some comments and I can provide you some resources on that. Okay. So with that, this was our last special label, and let's just conclude this module because it's becoming longer now. So I hope this was informative for you guys, and thank you so much for viewing.